Good day, students. Before we start, ready with your textbook, and turn to page 14. It's on Chapter 2. Communication and Internet Technologies. You may pause this audio while you are doing so. Once ready with your textbook at front, you may play this audio again. The lesson main topic is data transmission under computer communication. The objectives of this lesson are: 1. To explain the direction methods used during data transmission. 2. To explain the method used for number of bits sent at one time. 3. To explain the method of synchronization between two devices. Let's begin with the lesson. First objective of the lesson. Direction method. There are three different methods. 1. Is called simplex data transmission. 2. It is known as half-duplex data transmission. And third, it is called the duplex or full duplex data transmission. In simplex data transmission means data bits are transmitted from sender to receiver in one direction only. An example for simplex is when a computer sending document data to be printed using printer. Next, in half-duplex data transmission means data bits are transmitted from sender to receiver in two-way or both directions but not at the same time. After a sender completes sending data, the receiver can start its tasks by sending data bits. It's like taking turn in doing data transmitting task. An example for half-duplex is when two people are taking to each other using a walkie-talkie devices. Each of them take turn to talk through the line by pressing a button. Once that button is released, the other person may proceed talking. The third is full duplex data transmission means data bits are transmitted from sender to receiver in both directions at the same time. A sender and the receiver can do transmitting tasks at the same time, without delays. An example for duplex is when a superhighway communication between devices or computer system connected to the Internet broadband phone line. The second objective in the lesson is: how many data bits are transmitted at one time? There are two different methods. 1. Using serial data transmission medium, and second, using parallel medium data transmission. First, a serial data transmission method only send one bit of data at one time. 1 bit by 1 bit of data bits transmitted in sequence along a single wire or a single cable. Benefit of using serial cable is there is no problem of data arriving at its destination out of skewing or synchronization. This method works well over long distance. However, this method has a slower rate data transmission. An example of serial is the use of USB cable. We will discuss on universal serial bus cable later in the next chapter. Another example is the use of a telephone wire used to send data from a computer to a modem for internet connection. Second is a parallel data transmission method is using several wires or many cabling medium. Here, several data bits are transmitted at the same time. If 5 wires are packed in parallel case, each wire is still transmitting one single bit. Thus 5 bits will be transmitted at the same time. The benefit of parallel wires: it has a faster rate data transmission. Example: a ribbon connector is used to connect the desktop to the printer. However, parallel cabling is not suitable for longer distance transmission. Skewing of data bits may occur and leads to out of synchronization. Another example of parallel method is used within the internal electronics of the computer systems. First, the pathways between the CPU and the memory all use this parallel transmission method. Second, the use of 8-bit, 16-bit or 32-bit buses allow much faster data transmission rates compared using a single-channel serial data. Third, an internal clock ensure correct timing of data transfer. And it should be synchronous in nature, since it is in a shorter distance. Thus skewing is not happening. The third objective of this lesson is the use of asynchronous data transmission and synchronous data transmission. First method is called asynchronous data transmission. Here data is transmitted in an agreed bit pattern. The data bits are grouped together with two control bits. These control bits is called a start bit and a stop bit. The main purpose of the control bits is to prevent data bits upon transmission may got mixed up. With start bit is sent at front, data bits next and ends with a stop bit. This would be impossible to separate groups of data as they arrived at recipient. An example of asynchronous method is the use of MIDI protocol. It acts as a communication interface between a music instrument and the computer system to store music notes. The second method is called synchronous data transmission. Here data is transmitted in a continuous stream of data bits. The data transmitted is accompanied by timing signals generated by an internal clock. This ensures that the sender and the receiver are synchronized with each other. The timing must be accurate here. Once data are safely received, the recipient will reassemble those bytes of data. This method has a faster data rate transmission when compared over asynchronous. Synchronous data transmission is most suitable to use in network communication. As for a final closure of this lesson, students' home activity will be: write up the lesson content in your flashcards, as we practice during lesson in classroom. You might need 3 pieces of flashcard for this lesson. Do not forget to complete this task on time. Best of luck, students.